Dear students, today we are going to talk about binary operation. So let us begin. So given a non-empty set G, binary operation on a set G is nothing but a function from G cross G to G. Now we already know that G cross G is actually nothing but the Cartesian product of two sets. So over here a set A is given to us and they are asking whether addition is a binary operation on set A or not. So let us see whether it is a binary operation or not. So we should think what? We should think whether this addition, right? They are talking about addition. So whether this addition from A cross A to A is a function or not, that is what we have to check. So the question is how to check whether it is a function or not. It is simple. Let us find what is A cross A. So over here A cross A is going to contain 9 elements. So first of all let me write that 9 elements. So 1 1, yeah. So these are the 9 elements of A cross A. So what should happen is take one element of A cross A and you can see that 1 1 is present here. So we have to simply add them because addition is the operation, right? So what will be 1 plus 1? That is 2. Next, what is 1 minus 1? 0. What is 1 plus 1? 1. Are you getting my point? How we have defined it? It is defined as xy maps to what? X plus y, because we are talking about addition, right? So 1 1 is mapped to 2 actually. So what should happen is this A should contain 2, that is a reason, isn't it? Then and then only it will be a binary operation. But as you can see here 1 plus 1 is 2, but 2 is not there, right? 1 and 1 belongs to A, but what is 1 plus 1? 1 plus 1 is 2, which is not there in A, and therefore we conclude that addition is not a binary operation on A. So actually what should happen is, in the case of binary operation, if you want to check addition is a binary operation on a set A, then you take any two elements of the set A. Why any two elements? Because domain is our Cartesian product, that is A cross A. So take any two elements of the set A, add them and check whether whatever answer we get, whether it lies in the set A or not. If this is happening, then we will say that that operation is a binary operation. And note one thing, we can repeat the elements of a set. I mean the set contains 1 minus 1 and 0, so I can take 1 1 2 times, as you can see here. So if I take 1 and 1 from the set A, so 1 plus 1 is 2, but which is not there in A. Thus I will say that addition is not a binary operation on A. Let us move towards next example. Now in this example, close interval minus 1 to 1 is given. So the question is whether this is a binary operation or not. Again we will try to check, take any two elements of this set, add them and check whatever answer we get whether it lies in B or not. If that is happening, then we will say that it is a binary operation on B. Again here you can see that 1 1 belongs to B, but 1 plus 1, that is 2, that is not there in B, right? So therefore what we can conclude, therefore no, addition is not a binary operation on the set B. Moving towards the next example, here it is asked that whether addition is a binary operation on set of natural numbers or not. Again we have to do the same thing. Take any two natural numbers and check whether their sum is again a natural number or not. If that is happening, then it will be a binary operation on n. And if you think properly, you will wonder that it will be satisfied, because if you take any two natural numbers, in other words you are taking any two positive integers, so the sum of them is always going to be a positive integer, right? If I take 1 1, 1 plus 1 is 2, which is again a natural number. If I take 2 4, add them 6, it is again a natural number. So this will happen for any two natural numbers. So if I pick any two natural numbers, the sum is going to be a natural number. So yes, addition is a binary operation on n. Now the next question is whether subtraction is a binary operation on set of natural numbers or not. So if you take any two natural numbers, whether their subtraction is again a natural number or not, that is what we have to think. So if you think properly, 1 and 2 belongs to n, but what is the subtraction of 1 and 2? That is minus 1. Does it belong to n? No. So what is our answer? No, subtraction is not a binary operation on set of natural numbers. What about division? Is division a binary operation on set of integers? So if you take any two integers, if you divide them, we should get the integer back. Suppose if I take 4, if I take 5, what is 4 divided by 5? Is it an integer? No, right? So therefore, division is not a binary operation on Z, that is set of integers. Moving towards the next one, is multiplication a binary operation on set of integers? So if you take any two integers and if you multiply them together, do we get integer back? And the answer is yes. If you take 10, if you take 3, multiply them, you will get 30, which is an integer. If you take one negative integer minus 2, one positive integer like 3, minus 2 multiplied by 3, minus 6, it is again an integer. If you take 0, 100, multiply it, you will get an integer, and so on. So if you arbitrarily choose any two integers, the multiplication is again going to be an integer. So yes, multiplication is a binary operation on set of integers. So one more is there, whether this, now remember that binary operation cannot be always addition or subtraction, it can be combination of addition and subtraction as well. Now see how is the binary operation defined here. Binary operation is defined as a plus b minus ab, and they are asking the question whether this star is a binary operation on set of natural numbers or not. So what we have to check here, take any two natural numbers, let us say 2 and 3 in our case, and we have to check whether a star b is a natural number or not. So if a star b is coming again a natural number for any choices of a and b, then we will say that star is a binary operation on n. But if you see here, if I take a as 2, b as 3, what will be a star b? A plus b, that is nothing but 5, minus a multiplied by 3, that is 6, which is minus 1, which is not a natural number. So therefore this is not a binary operation on set of natural numbers. I hope you understood what do you mean by binary operation.